Good morning, student. Now let's start our new topic, hydrochloric acid. Now first we'll see that preparation of the hydrochloric acid. Here in the first preparation, the laboratory preparation of the hydrochloric acid. What is the definition of the hydrochloric acid? The solution of the hydrogen chloride gas in water, which means that as we learn the preparation of the HCl, we learn the preparation of the HCl gas, hydrogen chloride gas, that we learn through one reaction where we learn that when HCl NaCl when react with the H2SO4 concentrated, it convert into the H2O or HCl plus Na2HSO4. Okay, so this is the way we find out the HCl gas. Okay, laboratory preparation through we will get a dry HCl gas will got. Okay, now that dry HCl gas when dissolved into the water, this dry HCl gas when dissolved into the water, this form a hydrochloric acid. This form a hydrochloric acid. So how we will get this hydrochloric acid? So let's learn the first the preparation method through this. So here this beaker, here in this beaker water is filled. This beaker a water filled. Now from this, when we are making a dry HCl gas, that dry HCl gas is coming through this thin line pipe, and here it is coming. So what happened, that HCl gas is coming from this line and it is a very high amount of the HCl gas is coming and it's ready to react with the water and dissolve in it. So what happened, that here the pressure is generated already, atmospheric pressure is there. Here in this atmospheric pressure is there. Also here in pipe also the pressure is generated. So what happened, this atmospheric pressure is more than the pipe pressure. So when the gas is coming in it, so because of the higher pressure is present outside, so the water which is present in it, it's going inside the pipe in this, and it's going inside the pipe and then it's gone to this particular apparatus where the HCl gas is produced, and that HCl it's break down all the apparatus, because it's a very high amount of the heat is there and the high amount of the vapor also producing because of moist HCl is there. So everything, so some reaction is going on, and because of that all the apparatus will be break. So how we can manage to prepare the hydrochloric gas? So here they are making here the funnel. So this is the funnel. So on this pipe, this funnel is put. On this pipe a funnel arranged, and funnel is arranged just like that the surface area of the water and this outer surface of this funnel is just touch with each other. And when the HCl gas is coming, what happened here, the same scenario is there, that atmospheric pressure will come here, and in this pipe in this pipe also the pressure is there, but the very less amount of the pressure is generated, but here the high amount of, so definitely the water will go inside. But when the water will go inside, what happened, this is the way water will go inside. So when the water is go inside, so here the upper layer of, which means that this much of layer of water went into this funnel. So this much of area of the water went into this funnel. So what happened, the connection between water and this funnel is a disconnect. So the disconnecting the here the between water and the funnel. So what happened, immediately the air is generated, and if the air is generated between it, so the pressure, it will reduce the pressure, and automatically water will come down with the acid. So the same way, so many times this thing is happening. So the what happened, the water is coming inside because of the atmosphere and going inside, connection loss, and then water come back. So it will not go in this way, and it will not destroy the apparatus. Okay, so this is the way. And after some time the water and the water become concentrated HCl, hydrochloric acid. So this is the way in laboratory hydrochloric acid is made from the hydrogen chloride gas. Okay, so what is the question coming from it? So what is the advantage of the funnel arrangement? What is the advantage of the funnel arrangement in preparation of the hydrochloric acid? So first advantage is it's reduce the back suction. What happened here, why? Because of the atmospheric pressure is higher, and here the atmospheric pressure is low, so it will definitely suction up this water. So this, it will prevent the back suction, we can say, or reduce, it will reduce the back suction. Second, it's provide the larger surface area, which means that here the surface area become more, so the more water is in contact with the HCl gas, and it's provide a larger surface area to make a reaction and to make a concentrated HCl. So there are two advantage. Important question, give it reason, give an advantage, 2 marks or 1 marks. This type of question, advantage of the funnel arrangement in preparation of the hydrochloric acid. So it will prevent the back suction, and the second point, provide a large surface area. Okay, now the physical property. In physical property, first the color. The color of the HCl is colorless. Odor is a pungent and irritating odor. Taste, as we know, just like HCl, hydrogen chloride gas, most of the physical property are matched with each other. So the same, the colorless liquid, odor also pungent and irritating odor, taste a sharp sour taste because it is acid, and it is a volatile acid. Very important, it is a volatile acid because it is a liquid, so it is a volatile liquid, or we can say the volatile acid, and the boiling point is a 109.8 degrees centigrade is a boiling point. And action on the skin, which means if 1 drop or 2 drop is contact with the skin, so the skin become brown in color. So the stain on the skin, which dark brown, red to brown color skin stain will be formed on skin if is contact with the skin. So the action on a skin is just like that, very dangerous. Brown color will be appear on your skin. Okay, so these are the physical property. Only this thing you need to remember for the physical property, other thing you know very well. Now the chemical property. In a chemical property, first chemical property, acidic nature. We'll find out the acidic nature. As in the last time I told you how we can find out the acidic nature. When the particular acid is dissolved into the water, if it is form a hydronium ion, then it will tell us that it is acidic in nature. So, and another thing also we'll learn the indicators. Indicators also we'll learn. Which indicator? A blue litmus solution, then methyl orange, all these indicators. The same thing with this liquid also, the blue indicator, methyl orange, phenolphthalein, with all of them it's behave like same, just like a hydrogen chloride gas. So the same. So all of this tests also give a acidic property or acidic nature of the hydrochloric acid. Okay. Now another property, the property that HCl is a covalently bonded. Now you know covalent bonded because you learn already in a second chapter chemical bonding in that. So HCl is a covalent bond. You know what is the covalent bond? Sharing of the electron. Sharing of electron is called a covalent bond. So here the HCl is a covalently bond. Now another thing, its basicity is 1. Now what is basicity? Its basicity is 1. Very important question, student. Its basicity is 1. How we'll get what is the meaning of basicity and what is the meaning of why? How did you get this is basicity is 1? So for that I am giving you very important topic here. The some question asked in exam that what is the meaning of basicity. So if acid, for the acid we are always finding out a basicity. Acid give a basicity. Now what is the basicity? When any acid like ICL, when HCl is dissolved into the water, hydrochloric acid dissolved into the water, it will form a H plus or H3O plus Cl minus. Now this number of H plus ion, here H3O plus or H plus we can say. So the number of H plus ion which liberated in water, what reaction happen here? H plus is dissolved into the water, so it liberated H plus and Cl minus. It will form H plus and Cl minus in water. So the number of H plus ion which are liberated in water, that is called its basicity. Here the hydrogen have here in hydrochloric acid have one hydrogen. That hydrogen are liberated into the water as an ion form. So that is why the HCl have a 1 basicity. It is called basicity. Another acid I will take you example H2SO4. So in H2SO4, what happened? I'll show you a structure of the H2SO4. So it's look like, if I show you the structure of the so S H2, so OH double bond O double bond O, H2SO4 is like this. H2SO4 structure is like this. Now in this hydrogen will be liberated in a water. When it react with the water, this bond will be break. So this 2 hydrogen is liberated, so it form a 2H plus SO4 2 minus. So that is why for H2SO4 a basicity become 2. Okay, remember student, for H2SO4 the basicity will be 2. Got it? Suppose HNO3. So in HNO3, I'll just give you the examples through structure also, as well as some reaction through also you will get that, like this also, that H plus is liberated. So what you have to do, you have to react with the water and find out the how much hydrogen liberated into the water, and that many number of is called its basicity. So for acid only we are finding we can able to find out the basicity. For acid we have to, very important student, those who want to take a science in a 11th standard, they have to know about this, that HCl or all the acids can have its own basicity. Those who have this number, so those who have a hydrogen atom. Okay, now let's another example I'll give you, HNO3. Now HNO3 when dissolved into the water, it will form a H plus, or here you can write H3O plus and NO3 minus. So 1 H plus, that's why HNO3 have a 1 basicity. Clear? Now another example I'll give you, acetic acid, CH3COOH. Now here what happened, this acetic acid when react with the water, this hydrogen is not liberated in water, only this hydrogen is liberated in water. So what happened, it form a CH3COO minus ion plus H plus, or you can say H3O plus. So only this ion, only this H is liberated. So that is why acetic acid, no doubt acetic acid have a 4 hydrogen, but that doesn't mean that the acetic acid have a 4 basicity. How did you get the basicity? The number of hydrogen atom liberated into the water, that is called its basicity. So CH3COOH have a 1 hydrogen which liberated, other 3 hydrogen is bonded with the carbon, so they are not liberated in water, only this hydrogen. So that is why acetic acid have a 1 basicity. Okay, I will give you one example just for your homework, you can do it. Some example I will write here. H3PO4, H3PO3, H3PO2. What is a basicity of all 3? That is your homework. Find out and tell me. Okay, I will not ask you, you have to remind me and you have to tell me the answer. If you tell me and if you can't get it, I will explain you, but you have to try it. In exam so many times this thing asked, so you have to know about this. Got it? This is your homework, student. You have to do this. I hope you understand this thing. Okay, so this is a acidity, sorry, basicity. This basicity you have to find out. Is it clear? Okay, now for base, maybe some of you have a doubt to find out what is for base. So for base you can find out the basicity. For base you can find out a basicity. Okay, I'll explain you what is a basicity. For base, suppose a base NaOH. So when NaOH dissolve into the water, it will form H3O plus, or here H3, not H3O plus, it will form H plus sorry, NaOH plus H2O. So it will form Na plus OH minus will be liberated in a water, Na plus and OH minus. So that time for base you have to find out the numbers of OH minus ion. That is called its acidity. For base you have to find out the acidity. For acid you have to find basicity. So OH minus, base, for base number of OH minus, that is its acidity. So for NaOH acidity is 1. Okay, now another example, BaOH twice. So when it's ionized into the water or dissociate into the water, it convert Ba plus 2 plus twice OH minus, which means 2 OH is liberated. So its acidity will be 2. Suppose a AlOH3 plus water. So it's dissociate into the water, it will form Al plus 3 plus 3 OH minus. So it's AlOH3, its acidity will be 3. I hope you clear. So many times this type of question asked. So you have to understand what is a basicity and what is a acidity. I hope I am clear about it. If still you have a doubt, then you can ask me after watching this video. Okay, so here what we are doing, so it's we are doing the acidic nature. So HCl is covalently bonded, so it's sharing 1 electron and its basicity is 1 because it's form a 1 H plus ion here. So it's H plus or H3O plus ion which impart the acidic property of hydrochloric acid. Okay, because of it is imparting H plus or dissociate into the H plus or H3O plus ion, it is impart the acidic property. Okay, another acidic property. So when the HCl gas, HCl on dissolving in organic solvent such as toluene, this is toluene is one type of organic solvent, carbon tetrachloride, that is CCl4, does not give acidic property, which means that HCl can able to dissolve into the toluene and carbon tetrachloride, but it is not dissociate into the ion. It is HCl is not dissociate into the H plus or Cl minus ion. So that is why it cannot give acidic property with toluene and carbon tetrachloride. Okay. So here, because its molecule do not ionize in a organic solvent. Got it? Have you understand this point, student? I hope that you clear about this acidic nature, acidity and basicity. Okay. Thank you. We will learn next action with the matter tomorrow or next time. Until then, you have to do this homework. You have to do this homework, student. Those who know, they can give me answer after watching this video also, and those who did not know, they will find out, and next time if they can't able to get it, then I will explain you. Thank you.